So let's just move on further towards the question number 4. It says ABCD is a trapezium in which AB is parallel to DC and its diagonal intersect each other at the point O, and we have to show that AO by BO is equal to CO by DO. So let's just first of all draw the figure as it says ABCD is a trapezium. So let us suppose if I am taking the trapezium in such a manner, let us suppose this is my trapezium, and I am just calling it as nothing but A, B, C, D. So let us suppose this is the trapezium and this is A, B, C, D, and further it says that in which AB is parallel to DC. So as you can see, AB is definitely coming parallel to DC, and further it says and its diagonal intersect each other at the point O. So let us suppose if I am joining their diagonals and they are intersecting each other at this particular point, and let us suppose if I am calling this point as nothing but O. So this is the required figure for the question number 4, and further it says we have to show that let us suppose if I'll write it over here, we have to show that AO by BO is equal to CO by DO. So this is the thing that we wanted to show. So first of all, as you can see, the given statement is we have ABCD trapezium in which the diagonals are intersecting each other at the point O, and we just have to show this. So let us suppose if I'm doing a little bit of construction over here, and the construction is like I'm draw OE parallel to DC. Let us suppose if I'm drawing a OE particular line, let us suppose if I'm just drawing this OE particular line such that it is nothing but parallel to DC. So I am doing a little bit of construction in order to show this thing that AO by BO is equal to CO by DO. So the construction is like I'm drawing EO which is parallel to CD. Now let's just start the proof of this particular question. So as you can see over here, let us suppose if I'm starting the proof of this one. So as you can see, we have DE. We have this OE is actually parallel to DC. So if I'm saying that if in triangle ADC, I'm taking OE is parallel to DC by construction. If this is parallel to this one, so it implies that we can use the basic proportionality theorem, and using that we can say AE by ED's ratio is equal to AO by CO. We can say this by using the basic proportionality theorem. So by BPT we can write this, that AE by ED is equal to AO by CO, because we know that in this is ADC. In ADC triangle, this OE is actually parallel to this DC. So if it is parallel to this one, so we can say this ratio is equal to each other. Now let us suppose if I am moving on further towards the further triangle, let us suppose if I am calling this as equation number 1, and now if I am talking about in a triangle ABD, I am taking this triangle ABD. So first of all we know that OE is parallel to DC by construction. We know this fact, and further we know that DC is parallel to AB, and this is definitely a given statement to us. It is already given to us that AB is nothing but parallel to DC. So if OE is parallel to DC, DC is parallel to AB, means this OE is parallel to DC, and this DC is actually parallel to this AB. So definitely this OE is also parallel to AB. So hence from these two conditions we can say that OE is parallel to AB. So let's suppose if I'm calling it as 2, I'm calling it as 3. So we can say using the fact of 2 and 3, we can say that this is parallel to AB. And if OE is parallel to AB, it implies we can apply the BPT theorem over here, and we can say that AE by ED is equal to BO. We have this BO by DO. So let's suppose if I'm calling it as equation number 4, and I'm writing it over here that we are writing this by using the BPT theorem we are using the BPT theorem over here. So again, from the equation number 1 and from the equation number 4, from 1 and 4, we can say this thing that AE by ED is equal to AO by CO, and further it is nothing but is equal to BO by DO. So again, we can use these ratios as AO by CO is actually is equal to BO by DO, and further we can interchange their position as well, and we can write it as AO by BO is nothing but is equal to CO by DO, and this is the thing that we wanted to prove, that AO by BO is actually is equal to CO by DO in the trapezium ABCD. So this is all about the question number 4.